Hey everyone, welcome back to another Fusion tutorial. In today's video, we are going to make this putty knife. And this video isn't so much about teaching you how to make a putty knife, but we are going to do some pretty cool stuff with parameters. And it's pretty advanced stuff. I'm sure there's more advanced stuff out there than this, but we are going to create a bunch of parameters that you can change. So I've got handle width, handle length. This right here is the blade, so you can change the blade width, blade length, the tip thickness here, and then the handle thickness. And the cool thing about this is I have limits set on these parameters. So if I create an 18 millimeter handle, that works just fine. And let's do a blade. Let's just get this blade down further, maybe to 35. And we'll just change a few more things. Let's change the handle length. Let's say I tried to make this go down past 18. So the handle width limit is 18 to 40. And so if we try to take this down to like 15, I want you to pay attention to this model over here. So let me change this to 15. You notice it didn't change at all because the limit is 18. So even if you type in 15 here, it stays at 18. And I did that so it didn't break the model. And if this handle was any thinner, we'd run into some problems with this little circle cutout and stuff. So it's pretty fun doing something like this. You got to use your brain a little bit. You got to think of some some functions and some equations, and I'm going to kind of give you a sneak peek here. So to accomplish something like this, you have two sets of parameters. You have these favorited ones, which I kind of call the user parameters. It's what your users, the people who use this file, will change. And then you kind of have these behind the scenes parameters that actually drive the model. And we accomplish these limits with these min-max functions. And you can see it can get pretty crazy. We have a max function inside of a min function, which is inside of a max function. And all of these work together to create limits on the parameters so the file doesn't break, right? If we didn't have these limits, like up at the handle here, if we didn't have that limit of 18 as the lower limit, you'd run into problems with this model because this hole wouldn't have enough room. And so anyways, I'm going to teach you how to do that today. And it's going to be kind of a long one. I'm going to try to be pretty thorough about it. First, we're going to design the putty knife, and then we're going to spend the other half of the video working on figuring out these limits. So enjoy. Let's open up a new file and get started. Most of this model is going to be basically run by one sketch, the very first sketch we do. But before we do that, let's set up some parameters. And the thing about when you're going to do limits or functions like this, you almost have to know ahead of time that you're going to be doing it. Otherwise, it can get a little tricky. You have to go back and rename things, and it can be done, but you just have to understand why it's doing it, and I'm hoping you'll learn that today. So let's make all those parameters that we did in the previous one. And so our user ones I'm going to spell out, and then the ones in the background I'm going to just abbreviate. So we have handle width, and I'm just going to start that at about 20, and we'll hit OK. We have handle length. So these are pretty much placeholders at this point. We're going to do blade width and blade length. And these numbers don't mean anything right now. You can make these whatever you want. Okay, we have a few more. We've got blade tip thickness. We'll just name that, and we'll do 0.6. And then what was the other one I have? Handle thickness. and we'll start at 6 millimeters. Okay, so now we basically need to retype these out, but with limits. And I'm just going to go ahead and star these right away. When you star these, it puts it up into this little favorites folder. And this down here can get a little messy, the user parameter. So you can always hide that by just clicking the star. And now you only see the favorites. So the user of your model will only see what they can actually change. Okay, so let's add the rest, and I'm going to speed this up. I'm basically going to abbreviate these HW, HL, BW, BL, and at the end, and then I'm going to put limit. So I'm going to do handle width limit. And for now, I'm just going to have it be the exact same as above. So I'm going to speed through this so you don't have to watch this. Okay, so I have now my limit ones that the user will not see. So if we hide the user parameters and just have favorites, you can just see the ones that I've starred. And these down here, these 6 down here are really what's going to drive the parametric model. So, okay, let's get out of here and let's create our first sketch. So we're going to create a sketch on this bottom plane, and I'm just going to draw a rectangle. So hit R on the keyboard for rectangle. I'm going to make this a center rectangle, and I'm going to start drawing it here. And we already know our distance. So this is going to be the blade of the putty knife. So this left number is going to be blade length, and I'm going to do my limit. So blade length limit. Hit tab to do the other one, and this is going to be blade width limit, and then I can hit enter. And now because we put those values in there, it makes it 40 by 60, which is what we typed in the parameters. Let's do another rectangle, and this is going to be handle length limit, tab over, and handle width limit, and then hit enter. Now I want this handle, this line right here, the center of this line to be connected to the center of this line. So I'm going to use the midpoint tool, click this line, and now these are connected no matter what size they become. So let's finish sketch, and there is our basic putty knife. And we can do the next step pretty easily. We're just going to click on these sketch profiles, hit E for extrude, and we know this one is handle thickness limit. And I'm going to hit enter. Okay, so the next step will be to add this little bevel on the putty knife blade. So let's draw a sketch. So we'll click on the sketch button, and we're going to draw a sketch right on the face of this solid body. And I'm going to hit P for project, and I want to do, there's 2 choices. You can do the body, which if you select this, you basically, it outlines the entire body. And this right here just specified entities, just like I said. So I can choose just single lines, I can choose whole faces, and we want this whole face. And we want to make sure projection link is checked. Basically, projection link will update the sketch depending on this face. So if I kind of get out of this view, as if we change the blade length here to be longer, this sketch, this projection that we are doing will also update with this body. So when we're doing something that's parametric like this, where we want to be able to change things on the fly, you have to make sure that projection link is checked. So I'm going to hit OK. And now you can see if I make this body invisible, it has drawn the outline of that face. So let's draw a line. So L for line, and we're going to click in this corner and drag up, and this will be the blade tip thickness limit. Oops, click right there, make sure it's going up, and then we're going to draw another line that goes up to this corner. So I'm going to finish sketch. Let's make that body visible again. I'm going to take this profile, sketch profile, I'm going to E for extrude, And usually if you're not doing a parametric model, you can just drag this over and cut it out. But since this is going to be parametric and the width of this blade might change, what we want to do is go to extent type, to object, and choose this side of that blade. So now, no matter how wide or thin we make this blade, it'll always extrude to this face. I hope that makes sense. Okay, let's do one more thing and then we'll kind of test it out a little bit. We'll do two more things actually. So we know we want this corner to be rounded, or this handle to be a perfect, right, like a half circle here. So let's create a bevel. So we're going to select a fillet, I guess, two of these corners, go to the fillet tool, and this is where we type in right here. We know that basically each fillet has to be the fillet, or the radius has to be half of the handle thickness or handle width. So we can just type in handle width limit. Remember, all of our parameters that are the limit ones. And this is just going to be divided by 2. And hit enter. So now no matter how wide we make this handle, these fillets will always be that handle width divided by 2. So it should always update perfectly. And we're going to do the same thing, or not with the fillet tool, but we're going to do something with this curve. Now, you could make this little design element however you want, but I'm going to kind of do a fancier curve. I always want the curve to start here and end here, or end on this line right here. So I'm going to do this a little differently. I'm going to go up to an offset plane, and I'm just going to drag this up a little bit, maybe by like 5 millimeters. I'm going to draw a sketch on that plane. I'm going to hit P for project. And again, I'm going to project the blade here. Make sure projection link is turned on and hit OK. And then I'm going to come over to conic curve. And I don't use this a whole lot, but it's perfect for this situation. So I'm going to click on this point. So it kind of locks it to that point, and then it locks it to this point, and then I'm just going to drag up. This doesn't really matter. You can kind of choose your shape how you want. You can just have it right here. But since this is parametric, I always want to like have a reference point and everything, so you can see how I can snap to this line, and I'm going to just bring it down to the center. Once you click, it's going to ask for, I'm not going to explain this right, the radius or whatever number this is, the RHO. No clue what that means, but I'm just going to choose 0.5. If you know what that means in the comments, or if you're curious, I think what you can do, go up to create. If you just hover over this, it gives you more detail about the tool. But let's do that again. Let's go to conic curve. Click here, click here. I'm going to find the center, and I'm just going to type in 0.5. So because we have the constraints on this curve, we have a constraint here, a constraint here, and a constraint in this midpoint. If this blade, the dimensions of this blade changes, this curve should also change. So let's finish sketch, and I'm going to select these, and we're going to extrude it to cut. So E for extrude, and I'm going to choose two objects, so the bottom here, and hit OK. So there is our nice shape. So let's test things a little bit. And I'm not going to go too crazy because I do know this works. And I don't want to mess up all of my numbers here and then have to change them back. So let's just do height or handle width limit. Let's change this to 30. And there you can see that changed. And I'm just going to bring this back to 20. So I for now, I want to keep these the same as up here. Let's try the blade since we have more stuff going on with the blades. So blade width, let's go up to like 100. And then you can see that curve updates. And I think this was at 60. You'll just have to trust me. It all works. Again, you can change the thickness at the tip. You can change the height of the handle, and it's all working great. Now, where this gets a little bit tricky is the chamfers and stuff. But you know what? Let's skip that for now and let's do one more thing. We're gonna create uh, a little less waste in the handle. So I'm going to. You could just leave it like this and put a hole here, and that would be fine. But then you're printing all of this waste. Remember, I'm always designing stuff for 3D printing, so I'm always looking for ways to decrease how much plastic I'm using. And since this is basically kind of like a throwaway putty knife, right? You're going to use it maybe once or twice and throw it away. It doesn't have to be super strong. So let's create a sketch here. P for project, same thing. We're going to project this face and hit OK. I'm going to use the offset tool, and we're going to offset this in by 4. Now I did -4 because a positive number was going out this way, and I want to be this way. So -4, hit enter, and then I'm going to draw a circle, and we'll make this like 8. That will be for like a little nail hole, and we'll finish sketch. Now let's extrude this circle out, because this is always going to go all the way through. Hit OK. And you notice my sketch disappeared. Once you create a sketch and then use that sketch to like extrude or something, it usually disappears. So then you have to go back into sketch and turn it back on. You can actually shut that off in your preferences, but I keep it on because half the time I do want it to disappear, but in this instance I don't. So now we want to extrude this down, but I always want to leave a millimeter of thickness here. So if I hit E for extrude, you can see a positive number is going to bring it up this way. But so this is going to have to be a negative number, which is the negative of the handle thickness, but then we want to keep 1 millimeter, so +1. So I'm going to do negative handle thickness limit, and then I'm going to add 1 millimeter and hit enter. And now we can hide that sketch. And if we just click on this face, hold shift, click on the bottom face. If we come down to this right, we're at 1 millimeter. So no matter how thick we make this handle, this will always be 1 millimeter. And like I said, that just saves a little filament. You could probably do the same thing for this handle. You could have two, or I'm not sorry, the handle, the blade. You could have two big rails coming down here to give you the strength, and you could hollow out maybe some of the center of this blade as well, and that would save some more filament. All right, so let's add one more design element to this before we start messing with all the functions and parameters. So I'm going to change this up just a little bit. So if you look at the timeline here, these last 3 features were hollowing out this handle. I'm actually going to go backwards a little bit. And the only reason I'm changing this is because I've made this model a few times, and I know there's going to be some failures unless I fix this sharp corner here. And this is something you would just you wouldn't know unless you've already done it. So I'm actually going to add a fillet here to round this out, which will kind of drastically change the shape of our putty knife. But it's going to make the chamfers or the fillets that we're going to add to these edges work better with our parameters. So I just went back a little bit to erase what we did in the handle, and then actually once we add this fillet, we can just drag this back and it'll update. So it'll be kind of cool. So let's add a fillet here, and we're going to add one here too, and I'm just going to type in 75. I think that'll be good. And that gives a nice rounded corner here, or a nice rounded edge. And I'm going to hit OK. And we are going to go back on our timeline and drag that forward. And now you can see it updated that handle. And I think that actually looks pretty cool. Okay, so let's add some chamfers. Now, generally I like chamfers better than fillets, especially on the bottom side of the 3D print. That's going to be on the print bed. But I actually want the size of the chamfers to be variable. So like I want it to basically be 0 here so it doesn't mess up the length of my blade. But then I want it to kind of gradually get bigger and then be constant around this curve. And so you can't do that with a chamfer, at least not very easily. And so instead we're going to use a fillet. And you can kind of get close to a chamfer with a fillet. So this is what we're going to do. We're going to do all of our filleting in this box right here, and I'll try to make this not so confusing. So let's just start with a constant fillet, which will just be right here, and we're going to make this 1. Now you can see how rounded it is if you look at this profile, but we can change the tangency weight, and the lowest you can go is 0.1, and you can see that kind of straightens it out. Now there's still a little bit of a curve there, but it'll basically look like a chamfer when you 3D print. So now we're going to switch over and do some, actually I tell you what, we might as well just do these two. So I'm going to hit the plus sign. We're going to do this one, and this will just be like 0.3 just to ease over those edges. And I'm going to do 0.1 tangency weight just to make that straighter. And then now let's start making this edge right here go from the 1 all the way down to nothing. And so let's add a plus, and we're going to select this edge, but now we're going to change this to variable. And you can see it gave me 2 arrows here, one here and one here, the beginning and the end. And this one is in blue, and if you come over here, that's actually saying that's the end. So and then the white is the start right here. So we want to change the end to 1, and we want to change that tangency weight to 0.1 again. So then it kind of blends in nicely with this other one. And we're going to do the same thing for this side. So I'm going to hit plus. We're going to do one here, and we'll change this to 1 and then 0.1. For the tangency weight. Now we want to do the bottom, except we don't really have a good starting stopping, right? So it goes from a 1 here down to a 0, but there's no break here. So we're going to kind of have to do that manually. So let's do another one, and we'll select this edge, and it selects the whole thing. So here's my start, and it goes all the way around to the end. But we can add some points. So we can actually, you don't need to do anything. You just come along this line, and you can see like a red dot. And if you get to a point, it'll show green. But red just means you're kind of placing it manually. And so we're going to place it pretty close to this edge here. We'll come over to this side, do the same thing. This doesn't have to be perfect. And we'll do another one there. And so now you can see we have a lot more points. And so our start is right here. We know that we want that to be 0. 0.1 is here. We know we want that to be 1. And we know 0.2 is this arrow. We also want that to be 1. And now it lines up pretty good, other than the tangency weight down to 0.1. And now we can hit OK. And so now on both sides of this knife, at about this point, we have the 1 millimeter, and it goes down to 0. And that should keep our, let's just double check here, and we're at 60 millimeters. So it didn't change the width of our blade. And like I said, this becomes important because doing this chamfer, this round over here, because when we start messing with blade width and handle width, when they get close to being equal, things will fail. So let's take remember we're messing with the limits here. These limit parameters are what drives our model. So let's just change this real quick. So the handle width is 20, and our blade width, which is right here, let's just take this down to 21. And you can see it still works, but you see how these two lines right here get a lot closer? That is the edges of our fillet that rounded this corner. So if we take this down to 20, it's probably going to fail on us. So let's take that down to 20. And there you can see it just killed everything. So I'm going to hit OK, and I'm just going to Control Z to go backwards. So this is why it's important to, or why we're doing limits. Now we know that the blade width has to be at least 1 millimeter bigger than the handle width. So we want to add that limit to this. And so we're going to kind of test everything. And when you're creating your own model, you're going to basically be changing sizes, see what works and doesn't work. And when you get to a point where it just doesn't work very well, you can add that limit. And that's what we're going to do next. So before we start creating these limits on these parameters, there's one function you really have to know very well. And even when you know it very well, as I'm about to explain it, it's going to get confusing because it still confuses me even though I totally get it. So let's just add a parameter, and we're actually not going to okay this. We're just going to kind of test it. So I'll just name it test, and we'll put an expression of 40. Now, do you see how the value changed to 40? Now what I can do is I could put like +4 here. So we just made an equation in the expression, and our value pumped out the answer to that equation. And you can also add other parameters to this. So height, handle width limit of which is right here equals 20. So the value is 20. So there's all sorts of things you can do, including create functions. And there's a function called minimum and maximum. So I'll start typing in max and hit enter. And how max works is you need two numbers, or maybe two parameters, or two equations separated by a semicolon. And what it's going to do is pick the larger, because max, of these two numbers, which is why we have a value of 6. If I change this to 8, now all of a sudden the value is 8 because it's going to pick the larger number. Now minimum is exactly the same thing, except it's going to pick the smaller number. So we could do handle width limit, semicolon, blade width limit, and we get 20 because handle width limit is 20 and blade width limit is 60. So the value is going to be 20. There's another thing we can do with this, and we can add a function inside of this function. So we have the one number of 18, but now we could add a max function in here, and let's just do like 10, 20. And remember, you have to make sure you get your parentheses right. So this outside parentheses here is for this parentheses for the minimum, and then we need one for the maximum. So now let's see if we can understand this. So this max is going to pick the bigger number between 10 and 20. So it's going to pick 20, but the minimum is going to pick the smaller number between 18 and the maximum number, which is 20. So if we were to change, let's see, if we were to change this to 19, now the value is 18, right? Because max is going to pick the 19 and the minimum is going to pick the 18. So the value is 18. Now you can even go deeper into this and add another function in here. So we could add another minimum function in here, and it gets even crazier. So let's walk through this because I just really want to hammer this home for you guys. So the inside one is a minimum 4 and 8, so it's going to pick the 4. The maximum is picking between 10 and 4, so it's going to pick the 10. And now the minimum is going to pick between the 18 and the 10, so it picks the 10, which is why we have a value of 10. Now, if you understand that, you can now start adding in parameters in place of numbers and even equations. So like you could do one of these as blade width limit +1. and it would run through this whole thing again, but with a parameter instead of a number. So if you've got that, and go back and watch these last 4 minutes again if you don't fully understand this, but we are going to use that to create limits for things. So let's start with a semi-easy one, and we're going to start with the handle width. So let's just look at this handle. Remember, we made this circle, this cutout, 8 millimeters, and we made the thickness of these rails 4 millimeters. So we have 8 plus 8, 16 millimeters, and we probably want some space here. So we never want the handle width to be less than 18 millimeters. Now, just from a comfort, because I've printed this many times, the handle really starts becoming kind of uncomfortable to hold past about 45 millimeters. And, you know, maybe someone with huge hands might want 50 millimeters, but really 35 millimeters has been the sweet spot. So let's create a limit to where the handle can't be smaller than 18 and can't be larger than, we'll say, 45. So I'm going to type this out and then I'm going to explain it. Okay, so let's do the hand width limit, which controls this width. So I'm going to come in here and I'm going to do minimum, and I'm going to do 45. Max, I'm going to do 18, and handle width. And remember, I have 2 parentheses at the end. Okay, now let's work through this. Do you remember in the beginning I said that these ones, which is what we drove the parameters with, these are what we entered when we were creating our sketches and stuff. This is going to get its value depending on the user parameters. So let's think about this. So we have a max function here. And so this function is going to take the bigger of these two numbers. So if handle width, it goes smaller than 18, it will choose 18. So let's say we put a handle width right up here of 17. Well, this max function is going to choose 18, which means it can't go lower than 18. Now, once we have 18 here, I'm sorry, let me backtrack. So let's say we put 50 for handle width. Well, this max function will choose the 50, but then when we get out to the minimum function, it's going to choose the 45. So basically, it's clamped it in between 18 and 45. So anytime we put a value for handle width up here, lower than 18 or greater than 45, it's going to default to one of those. So let's test that out. So remember, we're looking at expression and value. So right now the value is 20 because it is within the 18 and 45. So if I put this at 25, look what happens. This gets wider, it goes to 25. The value of that handle width limit goes up to 25. But let's say we type in 17 up here. Now, the thing I don't like about Fusion is because if we hide these for our users, it's going to say the value is 17 over here because that is the value of this parameter. But since this parameter isn't driving this model, it's kind of misleading. Remember, handle width limit is really what's driving the model. And now look, we have handle width at 17, but the value of the handle width limit is 18. So now we know we can't go under 18. Similarly, if we type in 46, it makes it super, super wide, but the actual width is not 46. It is 45. Isn't that extremely cool? So this is what I do to make sure my users of this model don't get confused. I'll put in a comment over here, and I'll usually just write something like the limit equals 18 millimeters through 45 millimeters. So now we know, let's bring an expression back out. Now we know that you have to pick a number between 18 and 45. So let's just go back down to 18. And 18 worked out really well because now we have a little space here and it can't go any smaller than that. If we did go smaller than that, it would start screwing up this hole. So let's move on to one that's a little bit more complicated. And we're going to go through all of these. Some of these are really easy, like handle thickness. You can just set a basic limit. But let's do the hardest one first, and then we'll do the easy ones for last, now that we're in the thick of it. Okay, so this is where whatever model you're creating, you're going to have to start doing some testing, right? So we have our handle width limit. We know we want those limits under handle width. So now let's do our blade width. So we know we have these chamfers or these fillets and stuff that could break if we change it too drastically. So I'm just going to kind of jump right to the point. Here's our blade width limit. Our handle width is set to 18 right now. So let's go to 19. And 19 still works. So we know the blade width is safe at 19. But and that is while the handle width is 18. So let's just try to make them even. Let's try to go down to 18. And now we have a huge error, and look, it basically breaks our entire model. So I'm going to hit OK, and I'm going to Control Z what we just did. And so now we know, oops, hopefully that didn't just mess. Oh, it didn't. Okay. It can get confusing when you start testing models and figuring out what's what. So, okay, so now we know we want at least 1 millimeter difference between the blade width and the handle width. But we also know if the handle width lower limit is 18, the blade width lower limit has to be 19, right? Because we know with the blade width 1 millimeter more than the handle width, it works. So we know our lower limit for the blade width. The upper limit we can actually just choose ourselves. And if I guess putty knives, I guess you could go up to like 6 inches, which would be like 150 millimeters. So you can do your upper limit however you want, whatever makes sense for your model. I guess you could technically still crash this model at certain limits, but I don't think anyone's going to print one that's bigger than like 6 inches. So we'll stick with 6 inches, 150 for our upper. However, in the middle, we know, so let's say we made this 35. We know our blade width cannot be 35, so we can't do a simple upper and lower limit to this blade width. We always have to make sure it's within the upper and lower limits, but it also sticks to the rule that it needs to be at least 1 millimeter more than the handle width. So this is how we're going to accomplish that. I'm going to type this all out, and then I will explain it at the end. So we're going to start with a max function. And remember, our minimum one, our smallest one is 19, since our handle width limit is 18. Then we're going to do a minimum of 150. And then we're going to do another max of blade width, semicolon, handle width limit plus 1. And let's close in all our parentheses. Okay, let's even see if I got this right. We'll explain it. Okay, so we've got a max min inception here. So let's go to the very inner one. So we have the max function, a min function, and a max function inside. So let's take this first function, which is a max. So here's our blade width up here. This function is going to take the bigger one between these. So you have your blade width or your handle width limit plus 1. So if this blade width goes lower than handle width limit plus 1, it'll always choose handle width limit plus 1. If we jump out 1, this next one here is the minimum. So it's going to take the minimum number between 150 and this max function. So if this max function ever goes above 150, which is the upper limit, it'll pick the 150. And then the same is true with this max function. If this number goes below 19, it'll always stick with 19. Now what this is doing is it's giving us a range, a limit of between 19 and 150, but any number in between there has to be at least 1 greater than the handle width. Okay, I think I have that right. Let's test it out. So we have our handle width of 35, and let's just do 36 to see if that works. And it does. So I put blade width at 36, and if we come down here to our blade width limit, it's showing 36. So now let's see if we type in 35, which shouldn't work. Now look, it doesn't destroy the model like it did before, because if we go down to blade width limit, our value is still 36, because it chose this as the number that makes it all the way back to the value. So it looks like, let's see, I think I screwed something up. It looks like my last comment for the limit of the handle width disappeared when we screwed up our file before. So you can actually you could actually do all these comments afterwards, because what you're going to want to do, especially if a complicated model, is go through and make sure everything works. So let's just do, and I think I've got one more to show you for handle length. So, or one more problem we might run into. So let's do a blade width of 150, because we know that's our upper limit. And it looks like, what do we have in problems here with that fillet? It looks like it's all working. Let's just make the handle bigger here. See, that looks way too big. I don't know if anyone will ever create something like that, but this is just for fun. And let's do the handle width, which has a limit of 40. Okay, for some reason we're getting a little error on this fillet, but everything seems to be working. So I'm not sure what the error is. I'll tell you what, let's get out of it and let's see if we can figure it out. So let's go into this fillet. And what is my problem here? Everything looks okay. So let's just hit OK and see if it fixes itself. And it did. So let's get back into parameters. I don't really know what the problem was there, but Fusion did not like something. Okay. So we have handle width and blade width set to their maximums. And look at handle length. Now we haven't put any limits on handle length. So let's bring handle length, which is handle length limit right here. Let's just keep bringing this down. 50, 40, and you can see the handle getting smaller. Eventually what's going to happen is it's going to get so small that it's going to start breaking this circle. So we may want to set a limit on the handle length to 40. So let's just do that right here. So let's do minimum oh, we're on blade length. What was my blade length? 40. So we want to be on handle length. Let's do, we'll do 100 for the max range. And we're going to do, where are we at? 30. And we'll do handle length. Okay. So it spit out a value of 60 after we did that. That's because it's referencing this parameter here, which is at 60. So now we have a limit of 30. We can't go lower than 30. So if I type in 20 here, you can see it doesn't update because the limit is 30 right here. So now we know the length of this handle will not break even at its extreme. And of course, we can take the handle length all the way up to 100. And there we go. And let's take handle width down to like 35. Let's get back down to a normal size putty knife. Okay. So those are really the most complicated ones. Again, when you're doing your model, I'm actually not gonna do the rest. So there's a few more we can do. We can do blade length limit. So the problem you might run in here is making the blade length too small. So let's say you took this to like 1 millimeter or 5 millimeters. You may break the model. So you'd want to set a limit on your length of the blade and the thickness. I think when I did my model earlier, I did it from 0.4. The limit's from 0.4 to 1. 0.4 becomes a little too thin right here, and 1 millimeter is almost too thick. And then what's this one? The handle limit. So how thick this is, and you might want to set your limit from like 4 millimeters to 10 millimeters or 8 millimeters or something like that. So I am not going to go through all of these and show you that. It would be good practice for you to do that. Just remember, it's not going to be any different than the handle width limit for these ones because we don't have to do a max inside of a min inside of a max. You just have to do a simple one. And just keep in mind, just start from the innermost to the outermost. And you can even type it in backwards, right? I always just typed it from left to right, but you could type in your max first and then come back and type in your minimum afterwards, if that makes more sense to you. But this video is already getting kind of long, so I think I'm going to leave it at that. And if you have any problems with these parameters that are left, let me know in the comments and I'll help you work through it.